so used to moving this thing, and now it's going to fall out. If I had log base 4 of 4, that's 1 log base 4 of 2. What's log base 4 of 2? Because you got to take the square root of 40 to 2. Right? Log base 4 of 1, 0. And log base 4 of 1/4. So when this thing is less than 1, this has got to be a negative power that makes it flip to become that. If this thing is 1, it's 0. If this thing is less than this, but not less than 1, it's got to be some kind of a root, some kind of a square root cube or something. Right? So one way to do a problem like, it's going to drive me insane.
It's like a closet door.
Yeah, exactly. It's really deep. Oh wow, it's really screwed up. All right, well, let me see if I can make one up here real quick. If I had log base 36 is 6, I don't think anybody had that. All right, that's not too bad, all right? What would this be? 1/2. One way to think about it is, what do you have to do to 6 to make it 36? Square. So you got to do 1/2 to 36 to make it 6. So what do you have to do to 3 to make it 27?
Cube it.
So what do you have to do to 27 to make it 3? Because cube root of 27. Yeah. Cool. All right. There it is. Thank you. There you go. All right. So any other questions from the quiz? So without graphing, so if I gave you, for example, what's the domain normally? What would the domain for 4 to the x be? No, you're thinking range. The range would be 0 to infinity. The domain would be negative infinity to infinity. It would be all real numbers. Yeah. So there's no way to make the domain anything other than that, which is simple transformations. Because if it's negative infinity to infinity, now move it over, it's still negative infinity to infinity, right? You guys semi with me? So the domain is going to be the same thing. I can plug whatever I want to in for x. It's just going to move down 5. The x's don't care about that. But what happens to the range now? If I move this thing down 5, it used to start at 0, now it's going to start at negative 5. It's crazy. It's crazy. Because now the asymptote's going to go where? The asymptote's going to go down 5, and the asymptote will be at
Negative 5.
y equal negative 5. Oh, cool. Right? And that, of course, is like the beginning point for your range. That's what asymptotes kind of do. How sad is that? So when you graph this, you have to show me the asymptote. And then it's going to look, roughly. Right? So you can give yourself a point. You can either do it using a base function, and then you have to move that guy down 1, 2, 3, 4, 5. Some of you guys had a problem where the x and y intercept was 0, 0, so you had to find one more point somehow to do it. Most of you guys had 2 separate x and y intercepts, so you just could plot those and then fill in the shape. You didn't have to use transformations on this one.
So you had to write the asymptote, like you had to draw that dotted line, or did you originally graph 2 functions? Could you just graph 4 to the x and then graph 4 to the x minus 5?
I love it. And you still have to show me the asymptote. Yeah. Because why do you have to do that? Two reasons. One, it's a part of the graph, and two, I specifically said show me the asymptote, right? But anytime you graph a function who's got an asymptote in it, it's just part of what the function's all about. You got to show me where the hell that thing is. All right. Yeah.
Problem quiz. How do you transfer log
So again, avoiding doing a lot of work for you guys. It's the same problem as this, right? Because what's the base on log? 10. So if I just have a log sitting there, that is base 10. So what happens here? Totally, because what an 8 and log 8 to a power and log base 8 are what kind of things? Inverse functions, right? This is the mathematical sign language for inverse. So of course they're going to cancel. That's what inverses do. That's what they do all day long. So the whole point of them is to kill each other. Yeah.
But if there was a power on the, like in that case, if there was a power on the M and it had been transferred to the left of the log,
So if it starts off looking like this, 7 to the 4 log base 7 of D.
If you cancel,
You can't cancel anything right now because there's something in the way.
yeah, put the 4 back on.
There you go. And now the 7 can reach the log base 7. I got the 4 out of it. So it'd be really smart to consider that I will probably put a problem very much like this on the test. I told you exactly the problem is going to be on the test. Let's see how many of you get it right. My stats class, I tell them exactly. There's a question that's on every test. And I have never, in the 17 years of teaching stats, I've never had everybody get it right. So, if you want me to tell you what's on the test, it actually statistically doesn't really help you.
You can try it out.
I do every time. I've told you everything's going to be on the test. Yeah, come on. That's not right. Oh, no, specifically, Jeff. That's too bad. You can want a lot of things. Oh, does anybody need, before I finish that sentence, let me make sure. Oh, anybody need a copy of the practice test?
Are we going to ask questions about that?
Yeah. Oh, no, you can just think about it. We have to do it. Who else needs it?
Same game? I mean, it costs me a little bit more. Alright. You guys are for free. Let's just ask. Now I don't feel so bad.
Yeah.
Can you help the intercept, the x-intercept on 1? The f of x to 3 or 3x minus 1?
Oh.
You said word.
All right.
No one can help me.
So, I kind of gave you some leeway if you transformed the base function to graph it and you kind of went back to answer the question, but I don't care what function you're dealing with. I don't care. I don't care what level of math you're in. I told you the story about I was in math 896 and I had to find the z-intercept of a function with 15 variables in it. So what did I do? I set all the other variables to 0. And you never forget that. How do I find the x-intercept? I make y.
0.
How do I find the y-intercept? I make x 0. I don't care what the function is. I don't have to teach you that every damn time. You know that's true. So if you have a function, how do you find the x-intercept? Set y equal to 0. So 0 equals 7 to the x minus 49. When you solve that, x is 2. So the x-intercept is 2, 0. Y-intercept, how do you get that? So what's 7 to the 0 minus 49?
Negative 48.
1 minus 49, good, negative 48. So the y-intercept would be... Now some of you guys did that, but you forgot that something to a 0 power is 1, not 0. So then it gets freaky, because then you're actually touching the asymptote. And some of you guys are like, what the hell? You did that to yourself. Something to the 0 power is 1, so be careful. You know if you're touching that asymptote. For an exponential, that asymptote really is, you can't touch it. In general, you can touch a horizontal asymptote sometimes, but for exponential, you can't. So if you do run into it, you did something wrong. Go back. Figure out what the hell happened. Yeah.
I have a question on D from the practice test.
Yeah.
So I factored up the e to the 2x, and then I know in our notes, like, we just like dropped e to the 2x, or like it turned into 0. Like, how does that happen?
So the point of that is e to the 2x cannot turn into 0. So it doesn't give us an answer.
Oh.
So if I have like e to the 3x times 4x minus 2 equals 0, right? So it started off as 4x e to the 3x minus 2 e to the 3. So for some reason, you didn't take a 2 out, but screw us, we just took an e to the 3x out. And then what do? You set each factor equal to 0. Well, when does e to the 3x equal 0? So that part doesn't give me any answers.
Okay.
Yeah. And the funny thing is, it's exactly how could you solve this if you're really not thinking? You could take a 3 out, and you can set each factor equal to 0. 3 equals 0, does that ever happen?
Nope.
So that part doesn't give us an answer. Because that part can't be 0. So that part doesn't give us an answer because that part cannot equal 0. So it's nothing new, really. And the idea of the asymptote kind of tells you this is going to happen. Can't be 0. So the only answer will come from there. Cool. I like it. So pulling that E out really focuses you on the only part that's going to give you any answers. Yes?
Did you go through number 87 on page 339?
Oh, good. Is that the one? Yes, good. Thank you. So at some point I wanted to do this, and now's a good point. So on the answer key, I just didn't think I had enough room on there for number 87. Which was 339. '87 is the one I got. It has this electric circuit. I like it. And it gives me the formula for the current. Because, for us, whenever we flip a switch, we see the light come on, but what actually happens is it takes a little bit of time, a very little tiny bit of time, for it to get up to full, brightness. So it's kind of related to this factor here. It's that little lag factor. It's such a small lag that humans can't really normally perceive it. So part A sounds a little freaky. Part A is a part that some students really, really hate. It doesn't give us anything to plug in. It just says solve for t, right? It doesn't actually say that. It says express the time as a function of the current. This is currently, no pun intended, what is a function of what? What is this? What form is this in? This is I as a function of t. So when I say that phrase, I want you all to understand what I mean. That means that I is by itself, and t has stuff done to it to make it I. I as a function of t. So part A says, write t as a function of I, which in other words is solve for t. So what do I have to do first to solve for t? Yeah, divide, multiply by the reciprocal, right? Get that fraction the hell out of the way first is what I would do. Hopefully that's what you meant. All right, get this thing out of the way first. So I get 13 over 60I equals 1 minus e to the negative 13t over 5. Yummy. All right, so what the hell do I do now? I can't do that ln yet. It's the whole idea of something's in my way, right? That happens a lot. I need the e by itself so I can attack it directly. And you can be smart about this. We see this kind of thing all the time. If a equals b minus m equals b minus a. These two could just switch places. I can add n, subtract, so I'm just going to, right? You don't have to make that weird sound. It was louder than I intended. So this can go over there, I can add that over, and I can subtract it over, so effectively they just switch places, and that's better because that's got the variable I want. Now I can do what? ln, cool. Cool. So if I take ln of both sides, be really careful. You cannot distribute that symbol, right? It's not ln times that, it's ln of that. So it's just got to stay like that. Too bad for it. What do you get over here?
Negative 13t.
Yeah, good. Those cancel. So you get negative 13t over 5 equals this business here. And then you're almost done. You almost got t by itself, right? Multiply by 5 over 13, negative, right? So you get t equals negative 5/13 ln of 1 minus 13/60 I. So I don't know, if you expected the model of a current in that circuit to be easier than that, I don't know what you're thinking. Right? I mean, so this is kind of, it doesn't actually have a lot going on, but it's actually a complicated circuit. So that's part A, and then part B says, after how many seconds is the current 2 amps? Well, now you see why you might want to do this. Because now where would I plug 2 in? It says after how many seconds is the current? Yeah, I is the current, so I just plug a 2 in, so T's already solved. Kick ass. Just got to plug a 2 in for I and figure out what the hell that is. Yes. Yeah, of course. Please do. That'll work out better. By the way, I got to make this point again. I made this point before, but I graded a lot of homework over the weekend, and a lot of it was not good. So you know who you are. This is a graphing class, so anytime it needs you to graph something by hand, I've said this whole thing before, I gotta say it again, obviously. Scale, work, points, shifts, if it's talking about shifting, you gotta show me all that stuff. That's the point of this class. One of the main points of this class is to get really used to everything that goes into the graph of a function. Because in calculus, you want all that down, so then you start talking about calculus stuff and what it says about a function. You want this kind of like there. You don't want to also have to learn this at the same time. You got it. All right. Be very you guys can work on quiz corrections. You can, if nobody's asking anything, you just call me over to your desk if you got a question. Because what's the base of LN? So what's the power in LN? How would they relate? No, not a coefficient. It's e to the ln. Because ln is inverse. It's in the power. E equals power is the opposite of ln. Since it's up in the power, it's oh.
Perfect.
Sure. Yeah. Oh, thank you.
Why would I, because I guess what I'm solving for x is the reason why it's 1, 0, and solving for this. It's actually really cool.
You show me the work, just plug like a one. When you tell me to one water,
For a little bit, then you put it in hot water. 1 is 3 weeks. Oh, okay. See, we didn't write that. Put it back in the hot water.
well, that's just me saying, it's the main deal on the points when you showed it in the. Show me how you got those. Once you show me the work of how to get them, then you can block out 4 laps. Plot is before you know what they are. You gotta show me how you get them. Alright guys, before I give you the answer key, number 87 is not on here, so it's a good thing somebody asked about it. It's up on the board. Yeah.
Oh, yeah, that's not a 30. Is that what you're saying? Because that's what 127 would have.
So for, while I was doing the corrections for
It's like,
54 and 56, I got the same answers. Was it that it wasn't wrong? You just didn't want me to actually divide until the very end?
This would be rounding way too much. So I didn't know, you don't even show this intermediate word because it doesn't help you. You don't want to round this at all. If you round it a little bit, if you actually plug in 4,000 times 1.41, you won't get anywhere near it.
and I know that
That's rounded way too much.
Okay.
Does that make sense?
Yeah.
So the work wasn't jiving with the answer you got because this is rounded way too much. But if you just plug this whole thing in your calculator, you'll get that.
Okay.
Pretty much, that's the way you have to do it. Yeah.
Does that work for the corrections? I just didn't put an XY table because it's right on the front. Unless you want me to show work on the XY table.
Oh yeah, and then okay, you got it. You're good.
Cool.
Cool. Thank you.
And then for A, is it? Oh, you didn't actually mean to do that, or just,
Yeah, I made this too long. It was just for these because this one it was just doing what was this one?
graphical addition?
Yeah. So you're fine there. It was these guys I needed to see because that was all about transformations.
Okay.
Yeah.
Is that meant to still be recording?
Not necessarily. I didn't know if anybody would ask a question.